Hey everyone. Ever get that feeling like, you could really use a security expert kind of looking over your shoulder as you code?
Uh-huh. Yeah, I can relate to that.
Today, we're going to be diving into AI-powered vulnerability detection. You know, all those tools that promise to automatically find and fix security holes,
Right.
are they the real deal or just hype? That's what we'll be exploring today.
Sounds intriguing.
We're going to be taking a close look at a research paper. It's called Closing the Gap, a user study on the real-world usefulness of AI-powered vulnerability detection and repair in the IDE.
Oh, yeah, I've heard of that one.
So this paper is really cool because it's based on a study with actual developers at Microsoft. They were using AI tools on their own live projects.
Wow, real-world applications. That's what makes this research so fascinating.
Exactly. It goes beyond just theoretical testing. We get to see how these tools actually perform in the trenches.
Right, the nitty-gritty of everyday coding.
So we'll be uncovering, what works well, what doesn't, and most importantly, what developers really want to see in these AI-powered tools.
It's all about making their lives easier and their code more secure.
Exactly.
So where do we begin this deep dive?
Well, the researchers in this study, they developed a tool called DeepVulGuard. It's a Visual Studio Code extension.
Okay, I'm familiar with VS Code.
So this tool uses AI to basically hunt down those hidden vulnerabilities in your code and suggests fixes.
Pretty handy.
And get this, it's powered by some pretty powerful AI models like CodeBird and GPT-4.
Oh, wow. Those are some heavy hitters in the AI world.
I know, right? These models, they're trained on massive amounts of code, so they can understand and generate code with pretty impressive accuracy.
So it's like having a security expert whispering in your ear as you code.
Yeah, it's a great way to put it. And the best part is DeepVulGuard doesn't just spit out, those cryptic error messages. It actually explains the vulnerabilities in plain English.
Oh, yeah, that's a big plus.
And it suggests fixes and even has a chat interface where you can ask questions and get more guidance.
Like a built-in security consultant.
Yeah, exactly. Now, to give you an idea of how DeepVulGuard works, imagine you're coding away, and suddenly the tool flags a potential SQL injection vulnerability.
Oh, that's never good.
Right. So DeepVulGuard, it tells you exactly where the problem is in your code, what's wrong with it, and then suggests a fix. It even explains how to properly sanitize user input.
Sanitize.
Oh, right. Sorry. Let me explain that quickly. A sanitization library, it's basically a set of pre-built functions. They're designed to neutralize potentially dangerous input from users. Like stuff that could be used to exploit those vulnerabilities.
Oh, okay, that makes sense.
So think of it as a safety net for your code.
Makes sense.
So this tool sounds pretty amazing, right? I mean, it can understand code, explain problems, offer solutions.
It does sound promising.
The question is, did it live up to the hype in the study? What were the results?
Well, the initial tests using benchmark data sets were pretty impressive. DeepVulGuard, it showed high accuracy and was able to fix a decent number of vulnerabilities. But as the title of the paper suggests, Closing the Gap, there was a bit of a gap between this benchmark performance and how it actually performed in the hands of real developers.
A gap, huh? That sounds a little ominous. What kind of gap are we talking about?
You see, the benchmark tests, they're kind of like a controlled lab environment. Everything is neatly organized and predictable. But real-world software development is more like a bustling city, full of unexpected twists and turns.
So the tool performed well in the lab, but things got a little messy when it hit the real world.
Yeah, that's a good way to put it.
Can you give me an example of that?
Absolutely. So there was this one instance where the tool flagged a URL. It thought it was vulnerable to redirection attacks.
Yeah.
But the developer knew this URL was actually safe because it pointed to an internal database.
So basically, DeepVulGuard was raising a false alarm.
Exactly. It didn't have the context to understand that the URL was safe within that specific project environment. And this issue of context, it's a recurring theme when it comes to AI, even with these advanced models like CodeBird and GPT-4.
It seems like AI still has some learning to do when it comes to understanding the nuances of real-world software projects.
It does. And that's where the insights from the developers in this study become so valuable. Let's delve into their feedback and see what they loved and loathed about using DeepVulGuard.
I'm all ears. Let's hear it. Okay, so DeepVulGuard, it's not quite a perfect security superhero. What did the developers think about using it? I mean, did they find any value in it despite those hiccups with context?
Well, it's interesting, actually. Almost 60% of the developers said they would consider using DeepVulGuard in the future, even after experiencing those issues firsthand.
Really? That's surprising. With those false positives and the whole hassle of customizing fixes, I would have thought they'd be ready to just ditch it.
It shows that developers, they see the potential. even with the limitations that these tools have right now.
Yeah, that makes sense. So going back to DeepVulGuard's performance, you mentioned that gap between the benchmark tests and the real-world code.
Right.
Closing the gap. That's
Yeah.
the title of the paper.
That kind of
Right, so
stuck
let's
with me.
say.
Well, in those initial benchmark tests, DeepVulGuard, it achieved an 80% precision rate.
80%.
That means out of every 10 vulnerabilities it flagged, 8 of them were actually real problems.
Wow, that's a pretty good hit rate.
It is. And it even managed to fix 13% of the vulnerabilities in a data set called Vul4J.
Full 4J.
Yeah, it's a data set specifically designed to test whether fixes actually work, without breaking other parts of the code.
Oh, so it's not just identifying problems, but actually coming up with solutions that don't create new headaches.
Exactly. But as we discussed those numbers, they shifted a bit when DeepVulGuard was tested with real developers.
Right.
The false positive rate, it climbed, and the fixes weren't always a perfect fit.
Clearly, there's more work to be done to close that gap, to
Right.
make these tools truly reliable for developers in their day-to-day work.
Absolutely, and that's why this feedback from the developers is so crucial.
Right.
The researchers, they categorize the feedback on the alerts and fixes. And it turns out that missing context, that was a major culprit for those false positives.
Okay.
For example, the tool might incorrectly identify a variable, thinking it's controlled by the user, when in reality it's coming from a safe internal source.
Ah, like that URL example we talked about earlier, pointing to the internal database.
Exactly. Another issue was incorrect pattern recognition. Sometimes DeepVulGuard would flag harmless code patterns as vulnerabilities.
Like seeing ghosts in the machine.
Uh-huh. Yeah, something like that.
So even though these AI models are learning at an incredible pace, they still need some fine-tuning to accurately separate the real threats from harmless code.
Definitely.
Now, what about the fixes? Were there any recurring themes in the feedback about those?
The researchers found that a common problem was the lack of customization in the suggested fixes. They might generate a fix that's technically correct, but it doesn't use the existing functions or libraries that the developer prefers.
Right. It might work, but it's not very elegant or efficient.
Exactly. It's like trying to fit a square peg in a round hole.
Uh-huh. I like that. So it sounds like the AI needs to learn to speak each developer's unique coding language,
That's a great way to put it.
using their preferred tools and style.
Right, because these prepackaged fixes, they end up creating more work for developers, who then have to adapt them to their coding style and project structure.
So it seems like the researchers got some really valuable practical insights from this developer feedback.
They did. They pinpointed several key areas where these AI tools need to improve.
Like,
Well, one major area is context. The AI needs to become better at understanding the context, both from the code itself and the developer's environment.
so it's not just about analyzing lines of code in isolation, but understanding how those lines fit into the bigger picture of the project and the developer's workflow.
Exactly. Another area is customization. The tools need to be more flexible, allowing developers to fine-tune the tool's behavior to their needs and preferences.
It's all about making these tools work for the developers, not forcing developers to adapt to the tool.
Couldn't have said it better myself.
And let's not forget about clear and concise explanations.
Right.
Didn't the developers in the study find those explanations helpful?
They did. But there's a catch. The researchers, they noticed that the AI-generated explanations, they were often too verbose and overwhelming.
Too much information.
Yeah, kind of like information overload.
Right.
Too much information could be just as bad as not enough. Developers, they need actionable insights, not a deluge of technical jargon.
So striking that balance between clarity and brevity, that's crucial when it comes to AI-powered explanations.
Absolutely. And this is where the potential of those chat interfaces really shines. They offer a more interactive and personalized way to get that clarity. The clarity that developers crave.
Yeah, you mentioned earlier that the developers liked using the chat feature. Why was that?
Well, they found it helpful for a number of reasons. They could get clarification on alerts, explore alternative fixes, and even discuss security best practices in a conversational way.
So it's like having that security expert readily available to bounce ideas off of and get instant feedback.
Precisely. The study suggests that AI-powered chat could revolutionize how developers approach security. Imagine having a virtual security mentor right there in your coding environment, guiding you through complex issues.
Now that would be a game changer. But chat isn't the only area ripe for improvement. The developers had some other interesting feature requests, didn't they?
They did. One of the top requests was for the tool to run in the background, automatically scanning their code as they work.
Yep.
having to manually initiate the scan. That was a major disruption to their workflow.
Yeah, it makes sense. Constantly stopping to run a scan would break their concentration and slow them down. It's like having to manually run spell check every time you write a sentence.
A very apt comparison.
Developers want these security tools to seamlessly integrate into their existing workflow, providing feedback without interrupting their flow.
Absolutely.
So what else was on their wish list?
Another big one was the ability to suppress irrelevant alerts. We've talked a lot about those pesky false positives. Being able to silence those recurring non-critical alerts, that would significantly improve the user experience.
It's about cutting through the noise and focusing on the real threats that need immediate attention.
Exactly. Developers, they want the power to customize the tool's sensitivity and prioritize the alerts that matter most to their specific project.
It seems like the developers in this study, they provided a wealth of practical, insightful feedback.
They did. It's clear they've given a lot of thought to how these AI tools could be improved. They're the ones who will be using these tools day in and day out.
So where do we go from here? What are the key takeaways for both developers and the people building these tools?
I think the biggest takeaway is this. AI has incredible potential to revolutionize security, but we need to focus on building tools that are practical, user-friendly, and seamlessly integrated into the developer's workflow.
It's about understanding the needs and pain points of developers and designing tools that empower them to write more secure code without sacrificing their efficiency or creativity. It's not just about building cool AI. It's about building AI that solves real problems for real people.
I completely agree.
But let's talk about the future for a moment. This study focused on a specific set of vulnerabilities and a specific tool. What are other types of security threats out there?
That's a great point. The researchers, they focused specifically on 27 vulnerability types related to web security, things like SQL injection and cross-site scripting. These are common and critical threats, but they only represent a small slice of the overall security landscape.
So there's a need to expand the scope of these AI tools to address a wider range of threats.
Absolutely. We need to develop AI models that can detect and fix vulnerabilities related to mobile apps, cloud infrastructure, and even emerging technologies like blockchain.
That's a tall order. It seems like AI has a lot of catching up to do to keep pace with the ever-evolving world of security threats.
It does. But the potential benefits are enormous. Imagine having AI-powered security tools that can protect us from the full spectrum of threats, no matter what platform or technology we're using.
That would be incredible. It would be like having a universal security shield, adapting and evolving to protect us from whatever new threats emerge.
At a perfect analogy. And as we develop these more powerful tools, we also need to ensure they're used responsibly.
What do you mean by that?
Well, we need to make sure these AI-powered tools are designed and implemented in a way that prioritizes human oversight and control. It's about striking that balance between automation and human expertise.
So it's not about AI taking over security completely, but about AI and humans working together, each leveraging their strengths.
Exactly. AI can handle the heavy lifting, analyzing vast amounts of code and identifying potential issues, while human experts provide the critical thinking context and final decision-making.
It's a powerful partnership with the potential to significantly enhance our security posture.
I agree. Remember earlier when we were talking about the gap between benchmark performance and real-world effectiveness?
Of course, it's hard to forget.
Well, this study, it really highlights a fundamental challenge in the field of AI for security. The difficulty of creating benchmarks that accurately reflect real-world scenarios.
How so?
Well, traditional benchmarks, they often use simplified or artificial code examples that don't capture the complexity and nuances of real software projects.
So the AI might pass with flying colors in a controlled test environment, but stumble when faced with the messy reality of a large, complex codebase.
Precisely. We need to develop more realistic benchmarks that incorporate factors like code complexity, project size, and the specific security practices of different organizations.
That makes a lot of sense. If we want to train AI to be effective in the real world, we need to train it using real-world data and scenarios.
Exactly. It's like training an athlete for the Olympics using playground equipment. They might excel in the playground, but they'll struggle on the Olympic field.
I love that analogy. We need to create training environments for AI that mirror the challenges they'll face in real-world software development.
And one promising approach is to leverage open-source software repositories. They contain vast amounts of real-world code that we can use to train and evaluate AI models.
That's a fantastic idea, but wouldn't there be some differences between open source code and the code used in commercial software? Wouldn't that create a bit of a gap in training?
There are definitely differences, but open source repositories, they offer an incredibly valuable starting point. And we can always augment these data sets with code from closed source projects, as long as we have the appropriate anonymization and consent, of course.
So it's about building a diverse and representative training ground for these AI security tools, exposing them to as many real-world coding scenarios as possible.
Exactly. The more realistic and varied the training data is, the better equipped our AI will be to tackle the complexities of real-world security challenges.
This is all incredibly fascinating, but we haven't talked much about explainability. You mentioned earlier that the explanations generated by DeepVulGuard were sometimes too verbose and overwhelming.
Yes. And that brings up a broader challenge with AI, often referred to as the black box problem. Many AI models are opaque, meaning it's difficult to understand how they arrive at their decisions.
So we might see that the AI flagged a vulnerability, but we don't know the reasoning behind it. It's like a magic trick, where we see the result, but not the process.
That's a good way to put it. And that lack of transparency, that can be a major obstacle to adoption. Developers need to trust the tool's recommendations. And that trust is built on understanding. If they don't understand why the AI is flagging something, they might be hesitant to act on it.
So how do we make AI more transparent and understandable? How do we open up that black box?
Well, there are a few approaches. One is to develop new AI models that are inherently more transparent. For example, decision tree models. They're easier to interpret than deep neural networks, which are often more complex and opaque.
So it's about considering explainability from the outset, choosing the right AI tools for the job,
Yeah.
based on how easily we can understand their decision-making process.
Exactly. But we can also develop techniques to extract explanations from those existing black box models. This involves analyzing the model's internal workings to understand how different inputs contribute to its output. It's like reverse engineering the AI's thought process.
That sounds incredibly complex. Is that even possible with these advanced AI models?
It's definitely a challenging area of research, but it's essential for building trust and ensuring that AI is used responsibly in security. If we're going to rely on AI to make important security decisions, we need to be able to understand why those decisions are being made.
It's about accountability and transparency. We can't just blindly trust a machine, no matter how intelligent it seems. We need to be able to look under the hood and see how it's thinking.
I couldn't agree more. Now let's shift gears a bit and talk about customization. We discussed earlier how the developers in this study wanted more control over the tool's behavior.
Right. They wanted the tool to adapt to their individual workflows and preferences, not the other way around.
And that makes sense. Every software project is unique, with its own coding conventions, security practices, and risk tolerance. We need to develop AI security tools that are flexible enough to adapt to these different environments.
So we need to move away from one-size-fits-all solutions and towards tools that can be tailored to the specific needs of each project and each developer.
Exactly. We need to empower developers to configure the tool to their liking. This could involve allowing them to define custom rules, adjust the severity levels of different vulnerabilities, and even integrate the tool with their existing security workflows.
It's about putting developers in the driver's seat, giving them the tools and the control they need to manage security effectively within their own unique development environments.
I like that analogy. It's about making security a seamless part of the development process, not an external force dictating rules and disrupting workflows.
This has been incredibly insightful. But before we wrap up this part of our deep dive, I want to address the elephant in the room. The role of human experts in this increasingly AI-driven world.
Ah, yes, a question on many people's minds.
Will developers still need security training in a future where AI is handling so much of the heavy lifting?
Right.
Will AI make human security experts obsolete?
Absolutely not. AI security tools, they're powerful, but they're not a replacement for human expertise. Developers will still need a strong understanding of security principles, best practices, and the ever-evolving threat landscape.
So it's not a case of AI versus humans, but rather AI and humans working together, each bringing their unique strengths to the table.
Precisely. AI can augment human abilities, providing valuable insights and automating routine tasks. But it can't replace the critical thinking, problem-solving skills and nuanced judgment of a trained security professional.
That's reassuring. It's not about AI taking over, but about AI empowering us to do our jobs better and more efficiently. It's about collaboration, not competition.
I couldn't agree more. And as AI continues to evolve, we can expect even more innovative security solutions that further enhance our capabilities and make the digital world a safer place.
But it's important to remember that technology is only one piece of the security puzzle, right?
Right.
What are the other pieces we need to consider?
Well, we need to foster a culture of security awareness across organizations, encourage continuous learning and development for both developers and security professionals, and promote collaboration and communication between these two groups. It's a holistic approach combining technology, education, and human ingenuity that will ultimately lead to more secure software.
It's about shifting the mindset from security is someone else's problem to security is everyone's responsibility. We all have a role to play in building a more secure digital world.
I wholeheartedly agree. By embracing a culture of security where everyone is empowered and engaged, we can build a more resilient and trustworthy digital world. It's not just about the tools we use, but the mindset we adopt and the actions we take.
Yeah, that's a really important point. It's not just about the technology, it's about creating that culture where everyone understands the importance of security and they actively participate in making the digital world a safer place.
Exactly. And speaking of building those better mousetraps, I want to circle back to something we touched on briefly earlier, the concept of multitask learning. The research paper highlighted how DeepVulGuard uses this technique.
Oh, right. I remember you mentioning multitask learning. To be honest, I'm a little fuzzy on what that actually means.
Yeah.
Can you break it down for me and our listeners?
Of course. So in simple terms, multitask learning is a machine learning technique where a single model is trained to perform multiple tasks simultaneously.
So instead of having, separate AI models for detecting vulnerabilities and then classifying them and suggesting fixes, we have one model that can do it all.
Exactly. That's what the researchers did with DeepVulGuard. They trained a single code-BERT model to predict whether a code snippet contained a vulnerability, pinpoint its exact location, and identify the specific type of vulnerability, all at the same time.
Wow, that sounds incredibly efficient. I can definitely see how that would be a major advantage. But what are some of the other benefits of using this multitask learning approach?
Well, for starters, it can actually improve the overall performance of the model. Think of it like a student who studies multiple subjects. They develop a broader understanding, they become more well-rounded learners. Similarly, by training on multiple tasks, the AI model learns to extract more generalizable features from the code, which can boost its accuracy across all those tasks.
So it's not just about doing more, it's about doing it better. Are there any other advantages?
Definitely. Multitask learning can also significantly reduce the computational cost of training and running the model. Instead of training and deploying multiple separate models, each specializing in a single task, we only need one.
That's a huge win, especially when we're talking about these complex AI models that require a lot of computing power, so it's faster, more efficient, and potentially more accurate. It sounds like multitask learning is a real game changer for AI-powered security.
It has the potential to be. On top of those benefits, multitask learning allows us to create more comprehensive and insightful security tools. By incorporating multiple tasks into a single model, we can build tools that not only detect vulnerabilities, but also provide deeper insights into their nature, severity, and potential fixes.
So it's not just about finding the problem, it's about understanding the problem and guiding developers towards the best solutions. That's really impressive. But I have to ask, are there any downsides to this multitask learning approach? It sounds almost too good to be true.
You bring up a good point. While multitask learning offers many advantages, it's not without its challenges. One hurdle is ensuring task compatibility. Not all tasks are well suited to be bundled together for multitask learning. If the tasks are too dissimilar, training a single model on all of them might actually hinder its performance instead of improving it.
So it's like trying to teach someone to juggle and solve complex equations at the same time. Those skills require very different cognitive processes and might interfere with each other.
Exactly. It's crucial to carefully select tasks that complement each other and contribute to the overall goal of the model. We don't want to overload it with unrelated or conflicting tasks.
That makes sense. So it's not just about cramming as many tasks as possible into a single model. It's about choosing the right tasks that can work together harmoniously. Are there any other challenges?
Another challenge lies in resource allocation. When training a multitask model, we have to decide how much emphasis to place on each task. If one task is deemed more important than the others, we might want to dedicate more resources to it during the training process.
It's like a teacher spending more time on a particularly challenging subject to make sure their students grasp the core concepts. So finding that balance between different tasks during training must be pretty tricky.
It can be. It often requires experimentation and fine-tuning. To find that sweet spot where the model performs well across all the tasks it's been trained on, it's a balancing act for sure.
So it seems like multitask learning is a powerful tool, but not a magic bullet. It requires careful consideration, expertise, and a bit of trial and error to get it right.
I agree. It's not a plug-and-play solution. But when implemented effectively, multitask learning can be a game changer, leading to a new generation of AI-powered security tools that are smarter, more efficient, and capable of providing deeper insights into the world of code vulnerabilities.
This has been a really insightful deep dive into the world of AI-powered vulnerability detection. We've covered a lot of ground, from the promise of these tools to the challenges they face and the exciting possibilities that lie ahead.
We have, and it's clear that this field is rapidly evolving with new research and innovations emerging all the time.
Before we wrap up, I'd love to get your final thoughts. What are some key takeaways you want our listeners to remember?
I think the most important takeaway is this. AI has the potential to revolutionize how we approach software security. But it's not about replacing human expertise. It's about augmenting it. We need to invest in research, develop practical and user-friendly tools, and ensure developers have the knowledge and skills to effectively leverage these advancements.
It's a collaborative effort, combining the power of AI with the ingenuity and critical thinking of human experts. It's about working together to build a more secure and trustworthy digital world. And to all the developers listening out there, stay curious, embrace these emerging technologies, and never stop pushing the boundaries of what's possible in secure software development. Thank you for joining us on this deep dive. We'll see you next time.